Hello everyone. Welcome to Python Challenge for All. Okay, let's see what we're going to do today. Today's topic is, cryptography. Lesson 95, symmetric encryption and decryption. So, as the first step to cryptography, we will use common key encryption and decryption. So let's try today's work. Okay. So try a very simple shared key scheme, which uses exclusive OR. Okay. This is a very, very simple one. So it's not practical at all. But anyway, we can learn about one way to implement common key or shared key encryption scheme. So exclusive OR, as you might know, in Python is a bitwise operation which takes 1 bit of 0, 1, and the operator is this hat, and 0 exclusive OR 0 equals 1 and 1 equals 0. But only when one of the two inputs are 1, it will be 1. So this is what exclusive OR does. So the scheme is try to take the exclusive OR of the input with some secret key. Okay, let's try and play with it. So the topic is shared common key encryption. Or you could say cryptography, but it's okay. Okay, so the system goes as first we define enc key to be something like that, something you like my secret key. Anything you like. And we will use it as a common secret key. And we will define a cipher function used for encryption and decryption, which takes two inputs, data and key. So data, both are bytes. So let's define cipher as data and key, and just return the bitwise exclusive OR results of each byte. So the return will be changed to byte, and it will be computed just a very simple list comprehension. So B exclusive or K for B and K in zip. That's the one. Okay, zip data and key. But actually, because the data might be longer or shorter compared to this encryption key, we need some technique. We will use technique to use from iter tools import cycle. So this will repeat the this enc key as long as necessary. So we will compute a cycle of key. Okay, so this will compute the byte-wise or bit-wise exclusive OR of the data with respect to key. So okay, that's all actually. Very, very simple. Repeat the key to match the input length as cycle key. Okay? And exclusive byte by byte. and return bytes by this scheme. Okay, that's all. That's all for needed for the cipher function. So let's try it with any text input. So as usual, we will have for underscore in, say, range. We will try up to 10 times. So original text is, as usual, input. And there's a kind of prompt. Text, what? Text. Okay, this is prompt. And it asks for any text. Just in case, we will print it. And also check the length of it. Okay. And then, as the cipher takes bytes, we will change this to encoded bytes. So orig text byte equals orig text dot encode. We will use the method encode, and the encoding scheme is UTF-8. Okay, so this will encode the original text into byte using UTF-8 coding system. So this is all for inputs. Now we can use the encoded bytes equals cipher, which we defined earlier. The first element is org text B, and the second element is this key, enc key. Okay, so how long, whatever the length org text B has, enc key will be extended to the same length and be calculated the exclusive OR with the enc key. So let's check how it looks like. Let's print the encoded byte order. So to do that, maybe this is a good tool, but very good library to encode the bytes. So we will use base 64 dot base B64 encode and enc B. So this will print out the bytes sequence very beautifully. Okay. So now we have, let's see how it looks like. Okay. Just let's stop here to see how it looks like. ORG text, sorry. Mistake. It should be bytes, not byte. Okay. So bytes returns the byte order, byte sequence. Okay, so let's run it again. And let's change this to rainy day. Rainy day. Okay, let's see it. Okay, so the rainy day, the length of 21 is changed to this byte length. Okay, fine. So let's continue. So after that, we will decipher it by decrypting, calling a decrypt function. Okay, we change this to, and then use the same function as decB. So we will just call it. So decoded bytes equals cipher, the same. Cipher encoded B and the same code, same key, common key. Okay. Now we have decB. We might want to print it here. I don't know. decB. And then we can do the reverse process of changing it to text by calling decode function. So decoded text equals dec b decode and UTF-8. Okay, so very good. Now we can print and check the dec text. Maybe we can write it as result text and what's wrong? Oh, here, a single quote dec text and just in case print length of dec text. Okay, this will be fine, I think. And maybe we might want to print it as well each time. Length, maybe not. Okay, let's run it and check that everything is fine with this. Okay, so Python is fun to learn. Good. So here, Python is fun to study consists of 23 characters. The binary representation is this, and encoded binary is this. No, encoded binary is this, and decoded binary is this. And when it decoded using UTF-8, it will change to just like the same character sequence, which is just like the original text. It can be long. Um, so today is a fine day, but it was raining yesterday. It can be long. Okay, but anyway, it works. Consisting of 50 characters, it's really fine to get just like the original text as a result. So maybe you can check yourself that everything is going well. Okay, I hope you like this. Very simple encryption scheme. Okay, lastly, maybe we can add something to make the code a little easier to use. So, for example, if the input is empty, we will exit from the loop. So not orig text, colon break. This is fine. And also, after each sentence, we will write the length of the code. Length of the byte sequence. So here will be like this. And also after conversion, we will add the same thing. So orig text B, and just do the same thing after dec B. Yeah, here. Okay. So dec B. Yeah, so this will be easier to look. Okay, let's try this. So let's change. Let's talk about Python rather than the weather. Is fun to study. Fun to study, and it's easy. Like this, okay? So in this case, the original sentence consists of 37 characters, and the same thing. Encoded text is 37, encoded by UTF, it's 37, and then encoded by common key, also exclusive at the same length, and decoded the same length, and decoded by UTF, it's the same. So it's, of course, the same. Okay, you can check that everything is fine. When you change the enc key, of course, the result will be a little different. But the final bottom line is that it always returns the same original text. Okay, that's all for today, I guess. So we learned about how to decode using encode and decode UTF-8, and then using cipher function, encode and decode. Okay, and also learned how to print the byte sequence into printable characters using base 64, B64 encode. There were lots of encoding, but I hope you learned a good part of it. Okay, we will continue. Hope you will be back next time. Bye bye.